All right, hello. This session I'm going to look a little bit more at statistics about mean and standard deviation. And I'd like to start with a question which we've looked at before, which is let a random variable x be normally distributed with a mean of 195, 139.5, and a standard deviation of 6.2. Now, I'm just going to put a little picture here, what that represents. 139.5, up 1 standard deviation, 2 standard deviations, 3 standard deviations, and every 6.2, up 45.7, up 6.2, 151.9, up 62, 6.2, 158.1. All right, and down 6.2, down 6.2, down 6.2. Now the question says, what's the probability that x is greater than 151.9? And it happens to be the score of 151.9 has a z-score equal to, if you take away the mean and divide by the standard deviation, it is above the average by 12.4 if you take away the mean. 12.4 divided by the standard deviation is 2. So at 2 standard deviations, there's an area of the curve from 2 to -2 of 95%. Now that means half of that is 47.5%. So the remaining percentage on this side of the line is 2.5%. So the answer is, what's the probability? The probability is 2.5%, or 0.025. The next question says find B. Now B is an X score, and they've got over here a Z score. Now let me just put, I can use this graph here. These are the X scores along here. But if I were to put Z scores, the Z score of the mean is 0. That's 1 standard deviation above, 2 standard deviations above, 3. 1 below, 2 below, 3 below. And they want, what's the probability of such that, where is Z greater than 0? Z greater than 1, sorry, Z greater than 1 is from here. It's this part of the curve. And they want an X less than B to be the same area as this yellow. Well, the same area is over here from Z is less than -1. So the thing is, I'll just put this little piece of trivia. The probability that Z is greater than 1 is the same as the probability that Z is less than -1. That's the yellow region. And that's the green region. And the Z of -1 has an X score of, well, we could use this formula. The Z of -1 has an X score of 139.5 over 6.2. You just have to come down 6.2. So that is 139.5 minus 6.2, and that's your answer, which is 133.3. So B is 133.3. It's that number there, 133.3. We could have just written that. All right. So this lesson, I want to look at the fact that you've got a mean the mean and standard deviation. Now, previous lesson, we already were told the standard deviation, but what if we're dealing with a binomial situation and where we have a probability of success, which is, we call it little p. And let's say we've got a point 60% chance of success. And the number of trials, well, I'll just wait for my screen because my screen's shut down. The number of trials is n. And so if p is 0.6, and let's say we repeat this 100 times, well, what's our expected number of successes? We call that the average expected number of x. We put a capital E and x. Well, that's the formula for the mean or the expected number of successes is n times p. So if n was 100 and p was 0.6, then NP is 100 times 0.6. We would get 60. So the formula of the mean is NP, which is 60. Now that's the mean is 60. But what about the standard deviation? Now the standard deviation is a little bit more tricky. It's the square root of NPQ. Q happens to be this probability of a failure. In this case, it's 0.4. So if you pick up your calculator and you go n times p times q, which is 100 times 0.6 times 0.4. Since my computer is on the blink and the screen stopped working, I'm just going to have to talk you through this. And if the computer comes back on again, I'll write it on the screen. 100 times 0.6 times 0.4. All right, you can get that formula, NPQ, but they've got NP 1 minus P in the formula sheet instead of Q. Oh, the screen's back on. Let me just check that we're still sharing. So when the screen comes on, I've just got to reshare the screen. So let me just reshare that. Stop presenting, if it works. And that should help me turn the whiteboard back on. All right, while that's working. Yep, that's good. And let's present again. My computer's been misbehaving. It's technology. Just got to run with it. And if then I'll just fill in what I've said. N equals 100. Now the expected number of successes, and it's gone again, is n times p, which is 60. Now I was working out the standard deviation, which is NPQ. So that's 100 times 0.6 times 0.4. All right, I get 24. So the average is 60, or the mean is 60, and the standard deviation. Now the variance is 24. Before we get the standard deviation, we've got to get the square root of that. So 24 is the variance, but now get the square root of 24, and you've got the standard deviation. Square root of 24. Standard deviation is 4.899. So 4.9, approximately 4.9. All right. I'm going to have to, I'm going to just mention this. You could write it down, and then I'm going to stop this particular recording and try to get my computer working. So for this particular calculation, probability of success is 0.6. The probability of failure is 0.4. And we have 100 events, 100 trials. Okay. So if we have 100 trials, that means that 100 times 0.6 will give us our average, which is 60. And to get the standard deviation, we have to get n times p times q and get the square root. So that is 100 times 0.6 times 0.4, you get 24. And then the square root of 24, you get 4.89. So the standard deviation is the square, it's gone again, square root of NPQ, which is the square root of 100 times 0.6 times 1 minus P, 0.4. And that's, from here, we can then repeat. Once you know that the standard deviation is about 4.9, and the mean is 60, you can go back to the standard deviations that we were talking about yesterday with the normal distribution, and you can find the probability of getting one standard deviation above and one standard deviation below 60. So that's about 4.9 below 60 is about 5.1 up to 64.9. So the probability of that is 68%. All right. So when I can, which I can't at the moment because the computer is actually a black screen. I think the video is still working, but the computer's off from my perspective. So if I ask you this question while I'm waiting, let's work through a couple. Get your pen down. If a dice is rolled 100 times, what's the probability of more than 10 sixes? The probability of more than 10 sixes. All right, a dice is rolled 100 times. What's the probability of more than 10 sixes? I'm going to try that one more time. This is fun. Battling technology. And chances are it's just going to go on the blink again. Yeah, I managed to get an equal sign drawn. Well, the probability of 1/6 is 1/6. The probability of not getting a 6 is 5/6. So to get the average, you need to go n times p, which is 100 times 1/6. So 100 times probability of a 6 is 1/6. So 1/6, and that is 16.6 recurring. That's the mean. The standard deviation is 100 times 1/6 times, and Q is the failure, which is 5/6. That's not a 6, and we get 13.8888. Get the square root of that, because then that becomes 13.888 is called the variance. Get the square root of the variance, and you've got your standard deviation, 3.73.